Okay, so welcome to this video. We're going to be discussing tutorial sheet 3, Math 1100, and question 1 to 5 are all about the same thing. So question 1 to 5 just requires us to complete the square first, and after completing the square, then you should be able to sketch. Now, there's a separate video if you want to learn how to complete the square. So here I'll just go directly into solving the questions. Yeah, so we'll start with question 1. So question 1, you notice a quadratic is always expected to have this type of formatting. This is the formatting of any quadratic equation. Now, for all question 1 baby questions, these guys that are given here, there's no C. There's just the first two parts, and they're asking us to complete the square. So C will be taken to be 0, and whichever method that you were comfortable with in completing the square, you learned to say you can either use the formula. So the formula is always best because you can never go wrong with the formula. This is the formula that you use to complete the square. And if you are comfortable with using the traditional method where you do it in parts step by step, it's still okay. But all we're saying, the answer is going to be the same. And when you're done completing the square, the whole idea is you being able to get the turning point, which is just this. This is the formula for the turning point. And the nature of the turning point can either be a minimum or a maximum, depending on the coefficient A. So if A is greater than 0, meaning your graph will look like this. So this will give us the minimum. That will be the nature of the turning point. Then here it will look like that, meaning you have the maximum. Okay, so this is a general background of quadratic equations. So now the first question is completing the square. So we'll start with question 1. So question 1, I'll just pick one baby from question 1. Yeah, so I'll pick the first one and the last one. So the first one is this guy here, which is x squared plus 4x. So this is going to be, the coefficient of x squared is already 1. So I'll just say x, then plus half of 4. So half the 4 there, then plus, minus 4 over 2 squared. So this is just going to be x plus 2 squared minus a 4. So this is what you get. Yeah, this is a completed square form. Even if you use the formula, you still get the same thing here. Then the last one, your number D. So D is simply 8x minus 2x squared. So there is 8x minus 2x squared. This can be rearranged to be negative 2x squared plus 8x. So this can be written as negative 2. Then this is x squared and minus 4x. Then this here is going to be negative 2. Then you have x minus a 2 squared minus a 4. Then this is going to be negative 2x minus 2 squared plus an 8. This is what you get. So this right here will give you the completed square form of question 1D. Yeah, so first thing that we need to do is to make the coefficient of x to be 1, right? So we factorize the negative 2. We get the 2 outside. This is what we did at this stage. Then when we reach this stage, we just write the x. Then the symbol there, which is a minus, half the 4, always half this. So half of 4 is just 2. Then I'll put this in brackets, square, then minus this number here squared. This is where the 4 is coming from. And then the 2 has to multiply everything back. So we get this. So this is how you would go about your question 1. You can try the rest. I've done for you the ones that I feel were a bit interesting. I can try number 4. So number 4 is simply IV. This is supposed to be 2x squared minus 5x. So 2x squared minus 5x. When we factorize the 2, this is going to be 5x over 2. This is what you have. Then from here, you can say x minus half of this is going to be 5 over 2 divided by 2, right? This will give you 5 over 4 squared minus this same guy here squared. Then this will be 2, 5 over 4 squared. This is going to be a 25 over 16. And this, when you are completely done, it's just going to be 5 over 4 squared then minus 25 over 8. This is what you'll get. Yeah, so if what we are doing here is confusing, guys, just be using the formula. I would really advise that you just master the formula. You should be able to attain the same marks that are needed. Just that the traditional method is better because you really appreciate the whole essence of completing the squared in depth. So, but the formula can still be opted for. The outcome will still give you the same. So like in this case, our A was 2, our B was -5, our C was 0. So when you substitute here, you get the same outcome. Yeah, so this is what you do on question number 1. So please feel free to attempt the questions that I'll be skipping, and you can always do your verifications. For those that are registered, you can always do your verifications on WhatsApp. It's easier that way if you send your rough work and you just ask for me to verify whether what you've done is correct or wrong. Yeah, so let's go to question number 2. Question 2 is the same thing, except now they want us to specifically tell them what the A, the H, and the K are going to be. It's the same thing again, except here there's a C, right? C is not 0. There's a constant now, right? So I'll do the first one and the last one, strictly sticking to that now, from now onwards. So the first one is 2x squared. So this is 2x squared plus 8. So we're on question 2A, which is 2x squared plus 8x then plus 1. So we want to complete the square here. So I'll do this in 2 ways so that you appreciate the whole thing, to say this is very easy and straightforward. So method 1, I'll use the formula, which is very easy. So I'll use the formula. The formula says putting anything in a completed square form is simply going to take us to replace in the following expression. So you simply get your A here, A is 2, your B here is 8, your C there is 1. So if we do the replacements, you get a 2, you have x plus, this is 8 over 2 and a 2, then this is squared, then this is plus your 4, your A and your C, minus your B squared, then you have your 4A. So this is now going to give us your 2x plus, this is going to be a 2, this is going to be 8 if I'm not mistaken, this is going to be a 64 over 8. Yeah, so this will be x plus 2 squared plus 1 minus 8. So you should be able to see that this is just going to be that. So this right here is what we need. Now they said we leave it in the form x plus is it h squared then plus k. So we just need to tell them what the letters are. So you just say where a is simply 2 according to this. What's in outside is a 2. Then your h is just a 2 as well. Then your k happens to be a -7. So that's what you do if you are to use method 1 to solve this guy here. You tell them what the h is. They were supposed to write a 2 there. Yeah, so the a is 2, the h is 2, the k is simply -7. So that answers your number 1, your question number 1, using method 1, right? I indicated to say if you want to use a formula, you do that. Now method 2, which is the traditional method of completing the square. So this is going to be, we deal with this first, factorize the 2 out. This is going to be x squared plus 4x. Then the 1 will be waiting outside this side. Then here we do the reverse. Half of 4 is just 2 squared minus the 2 squared. There's a 1 waiting outside. This is going to be 2 x plus 2 squared. Then this is minus 4. And this is plus 1. Here we can just multiply everything with a 2. So please note that the 2 only affects the things in the brackets. So this is what you're going to get. You get this. Then this is -7. This is what you get. The answer is still the same. 2 is that. H is still 2. And your K is still -7. You see that the outcome is still the same. Yeah, so however you do it, the answer has to be the same. So that's your method 1 and method 2. Yeah, so now let me do the last one on question 2. So the last one, which is having a fraction. So the reason why I'm trying to solve this The traditional way is because of the fraction. So it's 2x squared minus 1 over 4. So it's 2x squared minus 1 over 4x, then plus a 2, right? So we want to complete the square. So here we're just going to say factorize the 2 out. So if you factorize the 2 out, you're simply going to get this. This here is going to be an 8, then plus 1. So you notice that the traditional way, you could have either factorized the 2 everywhere. So this, someone would have said it's the same as x squared plus 4x then plus 1 over 2. It's here the same thing as what I did. So it's the same thing that I'm trying to show you here, to say you can either include this 2 which is outside, or leave it so that the 2 only affects the first 2 terms. So the 2 will just be coming at the end. If you don't factorize the 2 everywhere, meaning the 2 will just be hanging around there, and this is going to be x minus half of this is 1 over 16 squared minus 1 over 16 squared, and this is a plus 2. This will just be 2 x minus 1 over 16, 1 over 256, or rather, to make life easy, I'll just say 16 by 16, right? Yeah, so there's a 16 by 16 at the bottom, and there's a plus 2 waiting, and this is just going to be 2x minus 1 over that squared minus, then you have 8 by 16, there's a plus 2, and this is going to be 2x minus 1 over 16 squared. This here can be written as 2 minus 1 over 8 by 16. Common denominator there is 8 by 16. So it will be 2, 8 by 16 minus 1. So this is just going to be, okay, so according to my calculations, I'm getting a 255 over 128, because it will be 128 times 2, that's 256, right? Then 256 minus 1, that will be 255, then over 8 times 16, which is simply a 128. So here your a is simply 2, your h is just negative 1 over 16, and your k is simply 255 over 128. Yeah, so this is what you're going to get. Yeah, even if you were to use the formula, you should get something that looks like this, exactly like this. Yeah, no other way. Yeah, so this answers your question number 2. You can attempt the rest and verify. Then the next thing that you can do is the same thing here. They want us to complete the square, then tell them what the h and what the k is. So find the values of the constant h and k. Whenever they put something like this, meaning we're trying to complete the square. So what's the completed square form of this? So that's x squared plus 3x then plus 6. This is question number 3. So this is just going to be plus 3 over 2 squared minus, this is what, 3 squared over 4. I mean 3 over 2 squared, that's going to give us 9 over 4. So this is going to be x plus 3 over 2. Then this is going to be 6 minus 9 over 4. This is going to give us a 4, that's a 24 minus 9. That's going to give us a 15 over 4. So this is just a plus 15 over 4. So you tell them that the h is just 3 over 2, and the k is just a 15 over 4. So for these questions, question 1 to 5, please, before we do them, be pausing the video to try to work it out yourself, to verify with what we'll be getting. I've given you the formula already, and also the traditional method. So that's how you use videos as this when we are solving the hot tutorial sheet. You try to assess yourself whether you understand the topic or not. So now your question number 4, also the same thing. Now they want us to just get the sketch by the time we are done. So I'll just solve the first one. How you do the first one is how you do everything else. So the first one is asking us to first of all complete the square. So question 4a, I'll just solve this same guy here. This is x squared minus 6x then plus 8. So first and foremost, I'll ask you to solve this. If we solve this quadratic using the 3 methods, or rather I'll just say when you complete the square here, hope you should be okay that you are getting this. This is what you should be getting when you complete the square. So check it. Yeah, so check it out. This is the answer you're getting. So once you complete the square like this, you can now get the turning point. The turning point, you can solve the inside part here. Yeah, so let me use a different color. So you can solve the inside part, which is x minus 3 is equal to 0, meaning x is equal to a 3. So we have a 3 comma, the number which is outside, which is negative what? Negative 1. So that's your turning point. Now, the turning point can either be minimum or maximum. Because a is greater than 0, this is a 1, right? We expect the graph to look like this. So meaning this guy here is going to be a minimum. That's one thing you should know. Then the y-intercept as well can be gotten directly from the question. It's y is equal to the constant on the question is 8, right? So we have our y-intercept. The only thing that we are remaining with is to get the x-intercepts. So how do we get our x-intercepts? You solve the equation. So instead of resolving this using your product sum factor method, you can just get it at this point and say x minus 3. Because this and this is the same thing. Minus 1 equated to 0. You have x minus 3 squared is equal to 1. Then here now you square root. You'll get x minus 3 is equal to a plus or minus 1. Then now we are simply saying 3 can go on the other side. So this will just give us x is equal to 2 and x is equal to a 4. So we get the two answers. So now we have everything that we need. The two answers are simply 2 and 4. So we got 2 and 4. And we are touching the x-axis. I mean the turning point is 3, negative 1. This is 3, negative 1. That's the turning point. Then the y-intercept is simply your 8. So meaning the graph will just have to come like this and go like that. So this is how the graph is going to be. Yeah, so the graph will just have to pass through all the points that we've mentioned. Yeah, so we have the turning point, your y-intercept, and the two x-intercepts. So this is how the graph is going to look like. Yeah, so that answers your first question. These are the 4 things that you always need. Yeah, you need the turning point, you need the y-intercept, you need the 2 values of x where we are touching the x-axis. Yeah, so this is what we do on question number 4, on everything on question number 4. Maybe just to cement this whole thing that you are from learning, let me try to do question number 3 where there is a negative in front. Yeah, so what if you are given something that looks like this? Yeah, so number 3, that's 4. So number 4, 3. What if we're given something like a 4 minus 7x minus a 2x squared? So this is going to be the same as minus 2x squared minus 7x then plus a 4. This is what you're having. So first you complete the square. So we can easily use the formula here. Yeah, if we use the formula, we're just saying put it in this form. Completed square form is going to be a, then you have x plus, this is your b, 2a squared, then plus your 4ac minus your b squared over your 4a. This will be negative 2, x plus negative b, then you have 2, that squared, this is plus, you have your 4, then you have your c which is 4 minus negative 7 squared, 4 negative 2, then this is equal to negative 2 x plus, this is going to be 7 over 4, and squared, this will just give us 16, that's negative 32, minus 49, negative 8, this will be negative 2 x plus 7 over 4. Then this will be 9, 10, 11. That's going to be 1. That's going to be 8. So this is going to be a positive actually. Yeah, so this is what you get. Then this will tell you your turning point. Your turning point will be negative 7 over 4 minus 81 over 8. That's what you get. The y-intercept, which is the constant in the question, y-intercept is just going to be equal to y is equal to, you look back at your question, that should be a 4 if I'm not mistaken. Then when you solve this, is going to be 2. Then you say x plus your 7 over 4. Then this is a square here, there's a square. Then plus 81 over 8, equate this to 0. This is going to be x plus 7 over 4. There's a negative 2 here. This is going to be negative 81 over 8. Then this will be divided by negative 2, divided by negative 2. This will be x plus 7 over 4 squared is equal to 81 over 16. Then here now we square root this. When you square root this, it's simply going to give us a positive or minus 9 over a 4. Then when you take the 7 on the other side, this is going to be negative 7 over 4 plus or minus 9 over 4. So now we are having x is equal to negative 7 over 4 plus 9 over 4. This will just give us a 2 over 4, which is just going to be 1 over 2, or negative 7 over 4 minus 9 over 4. This is just going to be negative 16 over 4. This gives us a negative 4. So now we know where we're touching the x-axis at negative 4, and at half. The y-intercept is what? The y-intercept is a negative 4, is it? I mean a 4, it's a positive 4. Then the turning point is simply 81 over 8 and negative 7 over 4. Yeah, so meaning the graph has to look like this. So it's supposed to turn there, pass there, and also pass there. Yeah, because the turning point A is less than 0, so the turning point has to be a maximum. So this is negative 7 over 4, comma, 81 over 8. Yeah, this is basically what you'd get. So this answers your question number 4.3. This is the outcome for this guy. Yeah, that's what you have. And if you notice, there was a mistake, there was an error here, because you notice all the questions on number 4 are the same ones as the questions on number 5. So like this one, the third one, you notice it's the same thing as this. Yeah, so they repeated this. So this number 4 is the same as question number 5, right? So it's one and the same. So hope this is okay. This has answered your question. You can try the rest and try to verify with me. So maybe I should mention something like this, number 5. This is a very unique type of question where it has no real roots. Yeah, so f of x is equal to 2x squared and plus. If you try to solve this, you find that it's not solvable, right? The y-intercept, quite alright, is 4. That's a constant. But if you try to solve 2x squared plus 4 is equal to 0, this does not work. If you try to do this, you notice that x squared is equal to a negative 2. You cannot do this because this side is a negative. So meaning the graph is just on top. So it could be somewhere here, but then which side is it? It's on the positive side, right? Because all the outcomes here are always going to be positive on both sides. So the graph is just hanging somewhere there. Yeah, where the turning point is what? The turning point is, you have the turning point is going to be equal to, we say negative b over 2a. So negative b is what? Negative, there's no b, so this does not, there's no x value for it. So we can say 0, comma. If we say 0, comma something, that's going to be 4ac minus b squared over 4a ac. So that's going to be 4, that's 32 minus 0 over 8. This is just going to be a 4, so somewhere there. So it just turns and just goes there. It's actually here. Yeah, it's actually here. The graph is actually here, right there. It goes like that. Yeah, so there are such cases when you cannot get the x-intercepts, meaning your graph is on top or it's either at the bottom, depending on the constant they've given you. If it was minus c, if it was, let's say, I mean, there was a negative here and the minus c, meaning it would have been a negative 4 facing down like that. Yeah, so there are just those cases. But the only way you can do, find all the unique ways that they ask or phrase these questions is by trying out the same method that I did number 1, the same method that I used for number 1 and 3, try to use it again for the rest of the questions. Then you see the differences on how they phrase their questions. Yeah, so we're now on number 6. So number 6, they are simply going to be expressions that have to do with the roots. So I'll just give you a brief review of things you need to know before you even start solving. So we are dealing with quadratic equations, and one thing you need to know is that every quadratic equation is always expected to give us 2 answers. So let's call those answers alpha and beta, and you can always get the sum of those 2 answers by just writing negative b over a, and also you can know the product of those 2 answers by saying this, c over a. And also you can formulate back the quadratic equation if we know the alpha and beta, because we can just get the sum here, then get the product on the other side. In short, we are saying any equation is equal to the sum of its roots times x. So the sum of its roots, then times x, then plus the product, which is equal to 0. So this is basically what we are saying. The sum and the product must always be known. And another thing is that before you even solve a quadratic equation, you can tell the nature of its root. So the nature of roots that you're going to get. So if your b, using the discriminant test, so if your b squared minus 4ac, everything gives you 0, meaning you expect to get 1 real root. That's what you expect to get. Then if the discriminant 4ac is greater than 0, meaning you need to get 2, you expect to get 2 real roots. That's what we're basically meaning. Then if you have b squared minus 4ac, which is less than 0, meaning expect to get 2 complex or imaginary roots. Yeah, so 2 complex or imaginary roots. That's what we can get. So now look at your question number 6. Question 6, they're saying find the values of k for which the equation given here has 1 real solution. So if it has 1 real solution, meaning we're dealing with case number 1, right? Meaning the discriminant is equal to 0. So this is what we mean by the discriminant test. So the discriminant is just this value that is found inside that Chimabasi equation, the b squared minus 4ac. That's the discriminant. So now to solve or to answer your question number 6, we're just saying b, so question 6, b squared minus 4ac must give us 0. So now on our question, our a is 2, our b is p, our c is 1. So we have 2p1. So 2p1, so p, there's a 2p1, so we have this. So will be p squared minus 8 is equal to that, meaning p squared is equal to 8. We can get the square root, so p can either be plus or minus 2 root 2, because this here is the same as 4 by 2, right, which will just give us this. So p can either be plus or minus 2 root 2. Now here on the question, they said values. No wonder we're giving them both the plus and the minus, because they expected to get more than one answer. Yeah, so that's what we get. Then the same applies for number 7. They're saying find the values of k for which this thing has 2 real solutions. So we're just saying, meaning your a is what? Your a is 1, your b is 6, your c is k. So question number 7, we are having 16k b squared minus 4 is greater than 0. 16k, this is your a, your b, and your c. So your b is simply 6. Then your k is just there, greater than 0. So this is going to be 36 minus 4k is greater than 0. Minus 4k is greater than negative 36. Minus 4, so k is actually less than a 9. So now we're just saying all values that are less than 9 can actually be k. So k is in this interval. So this will stand as our solution because it's an interval. So k can come from any value that's between negative infinity and up to 9. So that's what you'll get as your number 7. So that's how we do number 7. All these questions here will require you to apply the knowledge of the discriminant test. So the same applies for number 8. They're saying the equation has two distinct real roots. Find the set of the possible values. It's the same thing again. Yeah, so here I'll just give you what to do. So we're just saying here your A is what? Your A is 1. Your B is 4k, coefficient of x. Your C is simply 4, right? So we're using this is greater than 0. So this is going to be, so your A, question number 8, your A is equal to 1. Okay. Your A is equal to 1, your B is equal to 4k, then your C is equal to 4 as well. So now we're saying B squared minus 4AC must always be greater than 0. So this will be 4k squared, 4AC should be greater than 0. This is going to be 16k squared, then minus 16 is greater than 0. So here you can tell that k squared is greater than 16. We can divide both sides by 16. Simply getting that, so meaning k is equal to 1. We can say k is equal to plus or minus 1 when you square root. Now here there's an inequality, so we're just going to test to say which portion, because we have negative 1 and then we have a 1. So if you select any number that's less than negative 1, if you square it here, you're going to get 100, right? 100, is it greater than 1? Yes. Then if you use a 0 there, this will be false, then here to be true. Yeah, for any number that you choose this side. In short, we're just saying k must belong to negative infinity up to negative 1, then union from 1 to positive infinity. So this is what you get as the interval or the solution set to get values of k that will give this thing here, this quadratic, to have two distinct solutions. That's basically what we are saying. Yeah, the same will apply for number 9. Yeah, so number 9, it's the same thing. They're just saying find the range of values for k for which this thing is greater than 0 for all real values of x. Yeah, so try this to see if you understand. So try it. This will be your personal task. Okay, so number 9, I've left it for you as a task to just try it out, then confirm with me what you get to see if you understand. We're just saying where is this whole thing going to be positive. Maybe you may get it from how I'll do number 10. So number 10, they're saying prove that the expression is negative for all its real values of x. This thing is always going to be negative. How can we know that? We're just saying replacing the discriminant for AC. So we're just going to say your B is what? Your B is 1, right? The coefficient of x, and square it minus your 4. Your A is negative 1, then your C is negative 2. If you try to punch this, this would just give you 8. This is landing us to negative 7. So you notice that we're getting a negative 7, which is less than 0. So this is always going to be negative for all values of what? Of x. In short, we're just saying that the graph can only be seen down. So this is maybe if we were to picture this, this is number 10. So I can rewrite this so I can rewrite this as follows. This is what you get. So this just means that the graph is always going to be down like that. Yeah, because the discriminant for AC is less than what? 0. We have a 1, a C, this is a negative, and because we are getting a negative 7, we are saying the graph is always going to be negative, meaning it's found below the x-axis for all values of x. That's what we're basically saying. Okay, so that's how we prove that the expression is negative. We just check the discriminant. It just means that the discriminant value is negative. Yeah, and discriminant, please don't forget, it's just the expression that is found in the quadratic equation under the square root, which is b squared minus 4ac. That's basically what we mean by discriminant. Then your number 11. Yeah, so number 11, we are saying find the range of values for k in order for the equation these to have two imaginary solutions. So if it has two imaginary solutions, it means the discriminant is what? 4ac is what? Less than 0, right? So we just have to replace your a, according to this, is 2, your b is 3 minus k, and your c is simply what? A 3, right? That's what we are having. So now we can do the replacements. Yeah, so your a is that. You already have your a. Yeah, so this brings us to question number what? Question number 11. So question 11, your a, your a is equal to, your b is equal to 3 minus k, then your c is equal to, so 3 and 2 and 3, bring it 2 and a 3. So we're saying the discriminant has to be less than 0. So where there's b, I can replace this, squared minus 4, a, then put your 3 there, less than 0. This will be a 9 minus 6k, then plus your k squared, minus, this is going to be a 24, that. Then this is going to give us k squared minus 6k, then this is going to give us a 15 less than 0. So we solve this. K squared minus 6k is equal to, rather plus 15 there. Plus 15 is equal to 0. So when you try to solve this, the product there is 15. The sum is negative 6. So what numbers can we multiply to give us 15 and then add them to give us a 6? So what number can we use? Can we use which numbers? Okay, so we are getting our p to actually be 9 minus, our product to be negative 15 because of a being 1, our c being negative 15, because 9 minus 24 is negative 15. So now we're saying if we decide or try to solve this, we try to look for the factors that can, two numbers, when we multiply them, they give us negative 15, then when we add them, they give us negative 6. So if it's proving hard to get, we're just saying this is going to be k should be any real value provided your k minus 6k minus 15 should always be less than what? 0. This here can be your answer as well. But if you do find the values, because here I'm not finding the values that can easily give us this, all the factors of 15, which is plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15, none of them give us can be added or subtracted to give us a negative 6. Yeah, so no wonder I'm saying this guy here should be not solvable. So we'll just write it like this. We'll just leave it in this form. Yeah, because we're unable to simplify it to the fullest. Yeah, so that will be your range. So here you can just say the range is all real numbers except where this is less than 0. Yeah, so anything, provided, we're saying all numbers provided our k squared minus 6k then minus 15 is always supposed to be less than 0. So this can be the answer for number 11. That's satisfactory as well. Then number 12, they're asking us to get the maximum value of the function is given that when you place f of 3 in the function, so meaning when you put 3 there, 3 squared and then a plus your 3b plus c, and also if you put f of negative 1, so if you put negative 1 in the expression, we have negative 1 squared and a minus b then plus c. These two are both giving us, because f of 3 and f of negative 1, they're all giving you 2, right? So we're equating these to 2 and also equating these to 2. So we've created equation 1 and equation 2. Then the maximum value of any function is just 4ac minus b squared. The maximum value, you can never get this. They're saying it's equal to what? Is equal to 10. That's what they're telling us. So now we can use the first two expressions, these two equations that we have here. So we're going to get a 9a plus 3b plus a c is equal to 2. Then we have a minus b, and then plus a c is equal to, this is also equal to 2. So we're getting this. Then this other side, we know what your a is. Your a is 2a, everything is 2 intact. They're saying the maximum value of the function. Yeah, so maximum value of this, meaning where the turning point is negative b 2a, comma 4ac minus b squared over 4a. So the maximum y value for this function is this part. Remember, I'm equating. This is where this is coming from. Yeah, so I've gotten the two expressions, which is when we replace 3 and negative 1. So this is what we're getting. Now we want to find the value in f. What's going to be the value of the expression when we say f of 2? Yeah, so we're just going to say, if we put 2 in the function to see what it becomes. So what is f of 2 going to give us? So we're saying f of 2 is just going to be, we put 2 everywhere. This will be 4a, then plus 2b, then plus a c, right? That's what we're interested in getting. So f of that, what is this going to be? Now, we already know from this expression, from these two expressions here, we can make n of these to be the subject. So if I decide to say, from this expression, I say 4ac minus b squared is equal to 40a, meaning we're already having this expression. Then we can decide to make this to be uniform. Okay, so a quicker way to go about number 12, we are already told that the maximum is 10, and we know to say whenever we complete the square of this, we know it should always take this form. We have a, we have x, let's say plus h, then we have squared plus k, and you know how your h is. Your h is negative b over 2a, and your k is what? 4ac b squared minus, over 4a, and the vertex, the point that we're given here is f of 3 and f of 1. So they're both giving us the same answer, which is a 2. So this, you can use this to get the x coordinate of the vertex, which is the turning point. So we are simply going to have, if this here, the maximum, if the value this side is 10, so we're just going to say we have the vertex middle point is just the 3 that we are given, f of 3, then plus the negative 1, then the middle point. This is just going to give us 2 over 2, which is simply a 1. So the turning point is actually going to be 1, 10. That's like the turning point that we need to be using. So in short, our equation is the same as a, x minus 1. Then here we're having a plus 10, because it always has to be the middle point. And we can simply use this now to get the other expression, because we need to know the value of a, right? They said f of 3 is equal to 2, so we can say 2, there is a. If I put 3 there, 3 minus 1, this is going to give us 10. Then this here is going to give us 2, which is going to be 4a, then plus 10. This is going to be minus 10, 4a. So it will be negative 8 for a. This will give us a to be negative 2. Now you know how the quadratic in completed square form looks like. So now we are having this, and we can easily get whatever we want here, because we know what a is. So now f of 2 is simply going to be negative this. You put 2 minus 1 squared plus 10. This is just negative 2 and a 1. Then this is plus 10. This will give you 8. So f of 2, the one we're looking for, will simply be your 8. That's basically how we go about number 12. Yeah, that's the easiest. Okay, so just a guide on number 11, where we said you could have left the answer to be in form of the way I had written it to be k's or numbers provided the k squared minus 6k minus 15 is less than 0. So if you complete it, so if you were to complete this, use the Chimabasi equation, the quadratic equation, you'll notice that you get your 6 plus or minus. This will just be the square root of that squared. This will be minus 4, then there's a 1 on the negative 15, then down here you're simply getting a 2. So you notice your k value will just be 6 plus or minus. When you're done inside here, you need to have a 60 plus 36. That's going to give us a 96, then over a 2. So this is the same as 6 plus or minus. This is just like 16 by 6, then over 2. This will just be 6 plus or minus. Here 4 root 6, then over 2. And this can be written as k is equal to 3 plus or minus 2 root 6. So now you have to test the answers. There is 3 minus this guy, and then there's also 3 plus 2 root 6. You just have to test this. So there's a 3 here in the middle that you test. This side you can use negative 10. This side you can use any number, let's say 10. So which region is this expression minus going to be true, right? So if you put a negative 10 here, this is going to be 100, then plus a 60 minus 15. So here you're simply going to get something that's big. This is false, because here it's going to be big. So that's false. That will not be true. This will be true. Then this side here it will be false as well. So meaning the final solution should just be between these two numbers that we've gotten. So k must actually be between 3 plus 2 root 6 and also between 3 minus 2 root 6. So just here, or rather some people say k must belong in the interval 2 root 6, then comma 3 plus 2 root 6. And they're open because the boundaries are not included. It's strictly less than 0. Yeah, so this is how you can actually finish off number 11. I just need to put it out there in case you're wondering how it's supposed to finish off. Yeah, so yeah, that's a proper way to conclude it. Then look at number 13. Yeah, so number 13, we are having show that the two roots of this are reciprocals of each other. So how can we show two roots are reciprocals of each other? We'll call one to be alpha, the other one to be beta. You notice that alpha times beta is just c. Your c is what? Your c is just going to be your a over your, your c over your a, right? So maybe I may rewrite this. This is just okay, so this is our number 13 here. We're seeing that the coefficient of x squared is just a, the coefficient of x is negative a and this and 1. So if you want to say the sum of this, so we have two answers, right? Let's say the sum of this should give us negative b over a, and also the other one is the product. The product is just going to give us what? It's supposed to be c over what? C over a. So if the two answers are reciprocals of each other, meaning they are inverses of each other, their product must give us 1. That's what we need to expect. So now you notice that here, if we were looking for the product, so therefore our answer is just going to be verified that the c is what? C is a, right? So I'll write my a there. My c is a, because the formula for their product is supposed to be c over a. So c is just a constant, which is a. Then the a should be the coefficient of x squared, which is also a. So you notice the answer there is what? 1. So this is verified. If two numbers are reciprocals of each other, meaning their product must be 1. Like if I give you this, to say there's 4, then 1 over 4. This should give you what? 1. So meaning the product of these two answers, we don't know what they are, but their product must also give us what? 1. So which is what we are getting. So we're just showing, or rather verifying, that their product is just going to be 1, and we've done it by dividing the c by the a, which is giving us a 1. So that has been verified. Then look at your number 14. 14, they're saying, show that there is no real value for t for which this equation has real roots. So now we're just going to say, if this thing has real roots, initially, the discriminant was supposed to be greater than 0, right? So the b is 2 minus t squared minus 4. Then there's a 2. Then our c is t squared, then plus a 3. This has to be greater than 0. If you solve this, this is going to be a 4t, then plus t squared, minus 8t, then that's going to give us minus a 24. That's t squared, right? The t here is squared. Then this will be greater than 0. If you try to solve this, it will be negative 7t squared, then minus 4t. This is going to be minus 20 is greater than 0. So I want to show that this will have no real value. Just get the discriminant of this part here. So what's the discriminant of the discriminant equation that we're from getting? So the first discriminant is that this thing has real solutions, real roots, meaning it has to be greater than 0. But then this thing here in response, or rather with respect to t, we're seeing that if we try to get the discriminant here, we try to check it out, it will have no real value for t, because if we try to put, we get our a here, our b is negative 4 squared minus 4, our a is negative 7, this guy is that. When you try to solve, this is 16 minus, that's going to be 140 times 4. This is going to be 16 minus, that's a 0, that's that, minus 1, that's going to be that. So when you do the difference here, you get a 4, that's going to be a 4, 5. You notice that this is negative, right, which is less than 0. So there is no real value of t for which this thing will be having real solutions. So we just get the discriminant of the discriminant equation. We're doing the discriminant twice. You do the first one, you form a quadratic. Now the discriminant of this quadratic is what we're trying to get. This is what you get. You get a negative. Let me just verify this with our calculator. So let's see. Our calculator. So this is just supposed to be, we say, 140 by 4. We're getting this, then minus a 16. We're getting a 544, right, which is negative. So yeah, this is what you'd get. So that answers your number 14. The reason is that we're getting a negative 544, which is less than 0. So there is no value for t for which this thing will have real solutions. Yeah, so that answers your number 14. Now we're going to number 15. So number 15, they're asking us to find the quadratic equation whose roots are alpha over beta and beta over alpha. So the few fundamentals that you have to know is that alpha plus beta is always going to be negative b over a, and alpha times beta is always going to be your c over a. And also you need to know that alpha squared plus beta squared is always going to be this expression here. So now, if you want to formulate a new quadratic when you know the roots of this other quadratic, we simply say to formulate any quadratic equation, we just need to get the sum, then multiply it by x, and then get the product. Then this is going to be the new quadratic that we're interested in. So we're simply going to get the sum of these two roots. We add them. That's the sum, or some people say this is the same as sx, then plus p is equal to 0, right? That's what we will need. So we need to get the sum first. Yeah, so if we want to get the sum, we'll just do the normal way of addition. Yeah, so we'll just say 1 alpha over beta, alpha over beta. So s alpha over beta plus beta over alpha. This is just going to be, the common denominator is alpha times beta. This will be alpha squared and beta squared. Now we know what the top guy is. The top guy is just alpha. This to alpha beta. Then down you just have alpha that. Then now we can do the replacements. The reason why we always have to use these replacements is because the only thing that we know is alpha plus beta and alpha times beta. So alpha plus beta is simply going to be your 3 over 2, right? Your negative b. So b is already negative, so we're negating it again, so it becomes positive. Then you know your alpha times beta is just going to be your c over a, which is simply going to be a 3. So we can do our replacements. This is going to be 3 over 2 squared minus 2 times 3. Then down, you're simply going to get your 3. Then this will just be a 9 over 4, then minus a 6. Then down you just have a 3. This can be written as a 3 over a 4 minus a 2. Then we can just break it down to give us, there's just going to be a 3 minus 8 over a 3. This is going to be negative 5 over a 3. That's your sum. So your S is simply negative 5 over 3. Then the product is just going to be 1, because these are reciprocals of each other. You notice this is a 1, right? So the answer that we're interested in is x squared minus the sum x then plus the product, which is 1. So the quadratic, whose roots are alpha over beta plus beta over alpha, is just this here, or we can multiply throughout by 3 to give us something that will be in a straight line like this. So this right here is the equation that we are looking for. So that's how you go about questions like number 15. It's still going to be the same thing, even if they ask about this expression here, except here we're not adding, here we're just solving, right? And you notice this is the same as this, and they're asking about the same thing. So technically when we do 16, it's the same as we've done 17, except on 17 we are formulating, we're now going to be formulating the roots, the quadratic equations, I mean. But on number 16, we're just solving for alpha and beta squared. So like number 1, they want alpha squared plus beta squared. We know what this is. This is the same as alpha plus beta squared minus 2 alpha beta. So you have to master this, or rather derive it. The only way you can derive it is if you just expand alpha plus beta, expand this. What do you get? You get alpha squared plus 2 alpha beta, then plus beta squared. You notice this and this has been formed, so we take this on the other side. So we'll have alpha plus beta squared minus 2 alpha beta, leaving us with alpha squared and beta squared. So this is equal to that. That's where this comes from. Then we can do our substitution. Alpha plus beta on this is just alpha plus beta is negative b over a, right? So it's negative 5 over 3 squared and minus 2. Alpha times beta is just c over a, so that's your 4 over that. This will give us 25 over 9 minus 8 over 3. So this will just give us a 1 over 9. That's what you get. Yeah. So hope you are seeing how this is coming about. This will be 1 over 9. Then for the second one, where they are saying you are having 1 over alpha plus 1 over beta, you know this is going to be the same as alpha beta, alpha squared plus beta squared, right? You've already found what alpha squared and beta squared is. You already know, so this is 1 over 9, right? This part on top. Then the down part is the same as 4 over 3. So now if you're just evaluating these two, this is just going to be 1 over 9 multiplying 3 over 4. This will just give us the 1 over 12. So this right here will just be a 1 over 12. This is 1 over 12. So that answers your number 16. Yeah, so number 16 has been answered. So it's the same thing now here on number 17. We're trying to derive, they're saying the equation, so meaning x squared minus, we need to get alpha and beta squared, then x then plus alpha squared and beta squared is equal to 0. What is this quadratic? So we're just going to, we already gotten this is 1 over 9 x. Alpha squared times beta squared, so this is the same as you writing it like this. Alpha squared and beta squared is the same as alpha and beta squared, so this is the same as 4 over 3, then squared, right? This is just going to be what? Your 16 over 9. So this is 16 over 9. So this is the quadratic equation, the one for the first case. Yeah, so we can multiply throughout by 9 to make it into a linear. So this is going to be 9x squared minus x, then plus a 16 is equal to 0. So this is what they wanted. Your question number 17A. Then on question 17.2, it's the same thing. X, the sum, plus this is the sum, then the product here is 1. When you multiply this by that, it gives you 1. That's where this 1 is coming from. So we already got this, by the way. We got it. It's 1 over 12. And I was saying number 16 and 17 are related or connected. So we have this. So meaning this will just be that, then plus a 1 is equal to 0. We can multiply throughout by 12. So this is going to be 12x squared minus x, then plus a 12 is equal to 0. So that's what you get. So this is going to be your answer for number 17.2. The number 18, they're saying, consider the quadratic equation where k is a constant. Find both roots. Find both roots of the equation, given that one root of the equation is 3 times the other. So one is, let's say, alpha, the other one will say 3 alpha, right? This one is 3 times the other one. So now if we add them, we'll get 4 alpha, right? And the summation is always going to be called negative b, which is 8, over your a, which is 1. So 4 alpha is equal to negative 8. I can divide here by 4. So alpha is equal to negative 2. Meaning 1 is negative 2, the other one is negative 6, right? Hope you are seeing this. So they are saying find the roots. So meaning 1 is negative 2. According to this, 1 is negative 2 and 1 is negative 6. We found them. I just used the rule to say the summation of roots is always going to give us negative b over a. That's what I used. Then the next one, they are saying what is the value of k? We know the product, which is negative 2. The product of these two roots will give us c over a. So c over a is k over 1. The product there is just 12. So meaning k here is equal to a 12. Hope this is okay. So that answers your number 18. So because here the key word was for you to master this part, to say one root is 3 times the other. So yeah, that's the part that got the question to be very easy. Then number 19, they are saying a diver launches herself off a springboard. The height of the diver in meters above the pool t seconds after the launch can be modeled by the following function. So this is your height equation that you get. How high is the springboard above the water? So when t is equal to 0, what do you get? You say 10 meters. So the answer here has to be 10 meters before any time has elapsed, right? That's what you get. Yeah, then use the model to find the time at which the driver hits the water. So you have to complete the square here. Yeah, so this is relative to your completing square method. So this is the same as negative t squared, then plus 5t, then plus 10. Yeah, so you can complete the square. Then for those that are registered, please feel free. Let me just see what you are going to think about this. Feel free to contact me, then I guide you. So you can handle this in 2 ways. Complete the square, then you get your highest. The t value is just negative b over 2a, right? That's what you do. So negative your b, which is what your b is 5. Then the down part is 2 and a 10 negative. So this is going to be a 5 over a 20. So this is going to give you 0. This is 20. So that's going to be 1 over 4. 1 over 4. Yeah, so 1 over 4 seconds. That's going to be the time that you get. But then you can rearrange it and complete the square. You identify your A, your B, and your C. Yeah, so I'll leave this for you to attempt. Let me not spoon feed you. These are application questions that you should always expect in tests. So yeah, let me leave this to those that have registered for them to access the solutions. Okay. Okay, so number 20. Yeah, so those registered, please contact me to just get the full solutions to this. The number 20, they're saying the width of a rectangle is 1 meter, 1 meter more than twice the length if the area of the rectangle is 10 meters per second. 10 meters squared. What are the dimensions of the rectangle? Okay, so here they're simply telling us that the width is simply going to be, so the width is just going to be 2 times the length, twice the length plus 1. Yeah, so the length is just L, right? Then you know the area is just supposed to be length times width, right? That's for a rectangle. That's what we're interested in. So I need you to picture that. So this is going to be, okay, let's say something that looks like this. Let's say this is the word length. Let's say 2. Let me say this. 2L plus 1. Then this is just L. Then the area, we know area is this part. So this is width, this side. Yeah, so let's just say we are going to have L. Then multiplying what? Multiplying 2L plus 1. This is going to give us 2L squared. Then plus L, you know the area has been given to be 10, right? That's what you have. So this is supposed to be L here. That's an L. So we're having 2L squared, 2L, then minus, this is going to be minus 10. So we are going to formulate a quadratic equation, and then we'll complete the square. So when you solve this quadratic equation, this is just what you get. When you solve this, you get 2 answers. The first answer that you're going to get is simply 2, and the other answer you're going to get is L is equal to negative 2.5. Now length can never be negative, so we take this one to be the length. So once you get your length, meaning the width can be gotten, because the width was just 2L plus 1, right? So this is going to be 2 by 2, then plus 1. This will simply give you a 5, which makes sense because the area was 10. So 2 by 5, right? Yeah, the area was this. Yeah, so the dimensions are supposed to be this. Yeah, so the language here that was confusing is the part that said the width of the rectangle is 1 more than twice the length. So twice the length and then 1 more extra. So that's where the trick was, you figuring out what we just wrote. That's how you get the 2 dimensions of the rectangle. Then look at number 21. Number 21 is just saying, find 2 numbers x and y whose difference is 10 and whose product is the minimum. This is also the same thing, except here we don't have any shape mentioned. We're just saying the difference, y minus x, the difference is what? The difference is 10, right? And the product should be the minimum. So from here, y is equal to 10 plus x, meaning x is equal to 10 plus this. So we can have 10x then plus what? X squared, that's the product. So this is x squared, then 10x. You complete the square here, you get x plus 5 squared minus 25. So you will notice that x is equal to what? This has to be what? This has to be okay, so this has to be, x has to be 5, negative 5, right? When you solve the inside part, gives you x is equal to negative 5. So the minimum number that you can possibly get is negative 25. Why? Because y is equal to 10 plus x. So you're simply saying 10 plus negative 5, which is just a 5. So y is equal to 5, that's what you get, and x is equal to negative 5. When you multiply these two, you get what? Negative 25, the guy which is outside. Yeah, so that's how you handle your number 21. Now the equation could have been different. You could have written x minus y. You see the same thing, right? You write your 10, meaning in this case you'd have found y to be negative 5 and your x to be 5 by the time you're done solving. Yeah, either way, their product is still going to be what? To be negative 25, which is a minimum. Yeah, because they didn't specify the order of how the difference is equal to 10. It could be however, but now we just went for the x minus, for the y minus x because we wanted to make y the subject. Yeah, so that answers your number. That answers your number 21. Then now number 22. Yeah, so 22 is on polynomials. So in the following problems, two polynomials PD are given. Use either synthetic division or long division to divide P of x by D of x. Express P of x in the form of P of x is equal to D of x multiplying the quotient then plus the remainder. So question 1, 2, 3 can be done using synthetic because the divisors are simply what? Linear expression. So the same way I would do number 1 is the same way you do number 2 and number 3. Then the last one, we have no option or no other choice than to use long division because the divisor is a quadratic. Yeah, so between the first 3 questions, I would solve the second one because the second one has a bigger power, which is x to the power 4. It will be easy for you to understand this. If you can understand number 2, meaning you can also attempt number 1 and number 3. So hope that's okay. Yeah, so number 20, this is number 22. So question 22, we're going to use synthetic for number 3. We're doing number 3, by the way. So we're using synthetic because the divisor is a linear fact, right? It's a linear expression. So I can just do it right here, actually. This can be done right here for me to avoid going back and forth. So you can just look at your question number 3. Number 2. I'll do number 2, the one with a bigger power. Yeah, I'm doing number 2. Yeah, so the divisor here is this guy here. This is what we are dividing with. So you solve this. This is going to be x minus 2 equated to 0. X is equal to 2. Then you put your 2 here. That's what you have. Then now you're going to get the coefficients of the quadratic in such a way that the powers of x need to be in a descending order. So the first power here is x to the power 4, right? So you need to have x to the power 3, you need to have x to the power 2, you need to have x, then you need the constant at the end. So I'll start with x to the power 4. What's the coefficient? It's a 3, right? So I'll write the 3 there. Then I'll write my negative 8 there. There is no x to the power 2, so I'll place 0 there. Then we have a 9. Then we have a 5. That's what we have. Now, because we have already put all the coefficients, I can just bring the 3 down here. Then 2 times 3, always you bring this number here. Then 2 times 3, that's going to be 6. Add this, you get a negative 2. Multiply this, you get a negative 4. This is a negative that. This is going to be negative 8. This is a negative 1. Just a positive 1, sorry. Yeah, because we are adding, right? This is going to be 2, that's going to be 7. So the last thing there is your remainder. The numbers you see down here give you your quotient, this part. So we're just going to say P of x is equal to, the divisor was x minus 2. Our quotient is this guy here, which is 3x to the power 3. Because the polynomial is to the power 4, the quotient will be 1 degree less. Yeah, so this is what you're going to get. Then plus the remainder, which is what? 7. So this here is your divisor, d of x. This here is your q of x. Then this here is the r of x. Yeah, so we've gotten the form that they wanted. So that's how we handle such questions whenever we are given a divisor that is in a linear form. You can always use synthetic division. Yeah, that's what you have. Now to do the last one on number 22. Yeah, so 22, they are simply asking us to divide. Now this is given in a form where the divisor is a quadratic, right? This guy is a quadratic. So we'll have no choice than to use long division. Yeah, so this has been done already. So now I'll do the last one, which is that by using long division. So the the guy we are dividing with, the divisor d of x is x supposed to be there. Then the polynomial is x to the power 5. Then this is plus x to the power 4 minus x to the power 3. There's no x to the power 2, so I'll put a 0. Then plus x, then plus a 2. So we always divide only using the first term. So x into x to the power 5 will be x to the power 3. Then you multiply with everything though. It's going to be x to the power 5. This times that. Then x times that is x to the power 4. Then 7 times that is negative 7x to the power 3. Then here we find the difference. This will go, this will go. This will simply give us negative x3. We bring this guy down. That's going to be 0x. We also bring this guy down. This is going to be plus x. The reason why I'm bringing these guys down is because at each particular stage you need to have the equivalent number of things as compared to our divisor. The divisor has 3 things, so we need to have 3 things at each particular stage. So when x squared divides x to the power 3 to just give us x, then when you multiply, that's going to give us x3. Then this is going to be minus x squared, then minus 7x. When you multiply everything here by the negative x, then we are subtracting. This will simply, this here will give us what? This will give us negative, yeah, and then this will give us positive here. It has to be positive. So this goes away. This is going to be x squared, then this is going to be minus 6x. Then you bring down the 2. Then x into x squared is just going to be 1. Then now we multiply with 1. That's going to be x squared plus x, then minus 7. And we find the difference there. So this is just going to give us negative 7x, then plus a 9. So we're just saying the function p of x is equal to x squared plus x, the divisor. The quotient is the number that the answer you've gotten here. This here is our q of x. Yeah, so x to the power 3 minus x, then plus 1. Then the remainder is negative 7x plus 9. So this is what you get. Yeah, this here is the divisor, d of x. And this here is your quotient, q of x. And this here is your remainder, which is r of x. So this is what you do if you're given a question and the divisor is a quadratic or it's a polynomial as well. So provided the power is 2 and above, you have no choice than to use what? Long division. So that's what you basically do. For the first 3, we are at liberty to use synthetic or long division because the highest power of x there is just 1. So that's what you have. Then the last question there is number 23. They're saying, given that this is a factor of this function, factorize this thing completely. So they've already given us one factor, right, which is this guy here. So we're going to use synthetic division to reduce this expression. So this being our last question, let me just do it properly here. So question number 23. So question number 23, we're saying x minus 1 is a factor. So this guy is a factor. Then the question is 2 negative 17. So there is 2 negative 17. This is x3, I think. This is x squared. Then we're having 22 minus 7. Minus 7. This is what we are having, right? This is what you get. Yeah, they are not asking us to solve this. They're just asking us to factorize it completely. So solving questions will be found on tutorial sheet 4. Here we're just trying to factorize this to the simplest form possible. So we're just going to write, solve this guy. X minus 1 is equal to 0. X is equal to 1. Put your 1 this side. Then write down these guys here, the coefficients, which is a 2. Then negative 17, then 22, then negative 7. We're just going to use synthetic. This is going to be 2. This is going to be negative 15. This is negative 15. This is going to be 7. It's going to give us a 0. So already we're saying x minus 1 is equal to this guy here is 2x squared then minus 15x then plus 7 is equal. This is not solving, so we'll just leave it like that. The remainder is 0, so even if you say plus 0, it doesn't change anything. Yeah, so this is what we have first stage. The second stage, you know how to break down a quadratic, right? This here is simply going to be the same as what? This is just going to be, this is a 14. The product there is 14. And the sum is negative 15. So what factors can we use? We can use negative 14 and negative 1, right? So we can just say minus 14x, then x plus 7. This now is going to be x minus 1. This is 2x, then x minus 7. Then you have minus 1, x minus 7. This is going to be x minus 1. This is 2x minus 1, and you have x minus 7. This right here is what you get as the complete factorized version of f of x. So that's basically what you get here for your tutorial sheet number 3. At least you have an idea of everything. The next time, the next video you're going to see uploaded is your tutorial sheet 4, where we just continue with polynomials until we reach inequalities and everything else that you need to know. Yeah, so thank you so much for watching. For those that want to register to access the full lessons and also physical lessons, feel free to reach out on the same number that you're doing verifications on whenever you are solving those questions that I skipped. Thank you.